In question 5, the fifth, sixth, and seventh terms of a geometric progression are 8k minus 12 and 2k. Given that k is negative, we have to find the sum to infinity of the progression. So the formula for sum to infinity is a upon 1 minus r. Now to find the sum to infinity, we need the values of a and r. For r, we know that if we divide two consecutive terms, so let's say if I divide the sixth and the fifth term, or the seventh and the sixth term, the value will be equal. So I can write this as minus 12 upon 8k. The sixth term divided by fifth term will be equals to the seventh term divided by the sixth term. Cross multiplying, we'll get 8k into 2k, which is 16k squared, is equals to minus 12 into minus 12, which is 144. So k squared will be equals to 144 upon 16, which is 9. K will be equals to the square root of 9. Now, as k is negative, so we'll take the value of k as minus 3. Now, once we have the value of k as minus 3, we can say that the fifth term will be is equals to, which is 8k. So 8 into minus 3, which will be equals to minus 24. The sixth term is given as minus 12. So the common ratio will be equals to minus 12 upon minus 24, which is equals to positive 1 upon 2. Now to find the first term, we can use the fifth term and use the nth term formula. So the nth term is a r to the power n minus 1. Now the fifth term is minus 24 is equals to a, which is unknown, into 1 upon 2 to the power 5 minus 1. So this will become minus 24 is equals to a into 1 upon 2 to the power 4, which is 16. 24 times 16 is minus 384. So the value of a will be minus 384. Now we have the values of r and a. We can apply it now to the formula for sum to infinity. So we'll write it as sum to infinity equals to minus 384 divided by 1 minus r. So this will become 1 minus 1 upon 2. 384 divided by 1 as 1 minus 1 upon 2 is 1 upon 2. So this will be 384 divided by 0.5, which will be equals to minus 768, which will be the sum to infinity of the progression.